Good morning. I am Anthony Black, Superintendent of the Southeast Research and Education Center here in Midville, Georgia. I would like to welcome you to our 2020 Field Day. This is our 13th Field Day since reopening in 2008. As most of you are aware, this is not our usual format. Due to the COVID-19 pandemic restrictions, we opted to host this annual event virtually this year. I am confident that this event will be just as informative to you as in years past, and I guarantee you will probably be more comfortable. This year we have numerous presentations for you covering our work here at Midville. We have a lot of ground to cover, but before we get started, I would like to thank all of our contributors. These include the Southeast Research and Education Center staff, the College of Ag and Environmental Sciences Research and Extension, and Southeast District Extension. I also would like to thank you, our local community, the producers, the agribusiness, and our local stakeholders that provide the support to keep these functions going year after year. I hope you find something useful, and as always, feel free to reach out to us or any extension agent at any time. Thank you.
Good morning. I'm Wes Porter, Southeast District Extension Agricultural Program Development Coordinator. I assist with the management and training of over 40 county extension agents in Southeast District. Midville is a very unique station in that it has the most extension agents collaborating with specialists and scientists on numerous crop trials and educational programs. I want to thank all the farmers, stakeholders, and extension and station personnel who have served and supported this facility over the years. I also want to thank you all for tuning in this morning, because you participating will help keep us relevant and reliable information flowing to you all from a year-to-year basis. Thank you very much.
Hi, I'm Wes Porter, Extension Specialist and Ag Engineer covering irrigation, precision ag, and machinery systems based out of Tifton, Georgia, there at the Tifton campus. So today I'm going to talk about some of the research that we're doing up here at the Midville Experiment Station, and doing a bunch of different things up here, but the particular project we're going to discuss today is a variable rate irrigation project where we're looking at irrigation scheduling and utilizing some of the more advanced tools and technologies for implementing that. And so in the first year of the project, this is a multi-year project that we hope to rotate through some multiple crops and different crops. First year we're focusing on cotton. You can kind of see in the background we've got a cotton field here. And if you look really closely behind me, you can see some flags out there with some tall antennas on them, that kind of pink and red ribbon out there on it. So if you notice some of those are our soil moisture sensors we have out in the field. And so what we're using those for is to verify and validate some of the irrigation work that we're doing. So we're using soil information from these fields, and so we've ran a soil EC meter out on the fields to collect soil electroconductivity. And so it's actually a Veris machine that we ran, a Veris 3100. And so we ran it out here. Normally on farm, we'd run that system at like 40 to 60 foot wide swaths. So out here, we actually necked those down. Since this is a research field, we ran it almost pass to pass. That machine is about 8 foot wide. And so we ran almost about every 8 to 10 foot to make sure we had a high density amount of information out here, so we can kind of look at it on a very, very dense scale and on a research size scale. Because when we start talking about plot work, of course, we're usually at 4 to 8, maybe 12 rows wide, whereas on a farm we're much wider. So we needed that denser data so that we can make those decisions on. So we use that soil EC data to do estimations of soil texture out in the field, and so we can use that for a lot of other things. But in this case, if we could estimate soil texture, we can get kind of an estimation of what our soil water holding capacity is. Then we can feed that back into a model and use that to make some decisions on our irrigation scheduling from. And so what you'll notice is we've got sensors spread throughout the field back there, and what we're using that for, that's in each one of our EC zones. And so when we set those sensors out and we put that information back into the model that we're utilizing, that I'll talk about a little deeper in just a minute, we're actually validating what the model's telling us and what it's estimating our soil moisture is at that particular time. And so again, we're looking at a cotton model, and the particular model we're looking at and we're working on is we've gotten some funding through a local organization, through a USDA NRCS grant, to do evaluations of the Lindsay Field Net Advisor Program. And so what that advisor program is this a soil water balance model that uses the information I've discussed to make in-season recommendations of irrigation scheduling for this crop. And so again, we're focusing on cotton this particular year, and how it works is it'll take rainfall information, weather data, crop growth stage, and it'll estimate what the water requirement is for that crop at that particular time. So to make sure that that model's running and estimating the exact water requirement for the crop, we put those sensors out there to validate in each one of those zones that the model is right. If the model's not exactly right, we try to go through and troubleshoot and see why it's not. What are we missing? Is it off by crop growth stage? Is it off by estimating soil water holding capacity of that particular soil type? Or is there something else going on there? And so we'll run it the entire year. We'll monitor soil moisture the entire year. We'll look in the different zones in the fields. And when we go to apply an irrigation application, the pivot that we're running under does have a variable rate irrigation system on it. And so that we're able to apply it based on our soil zones that are out in that field. And then of course at the end of the year, we'll evaluate yield from this field. And so when we evaluate yield, we'll get a good idea on what that looks like and be able to compare that back to a base rate irrigated cotton and to show, were we able to improve water use efficiency using this model? Was it similar to some of our other methods, or is there still room for improvement? So ideally, and when we've worked with most of these models, we've shown great improvement on that. And so some data will be shared in this talk, just a slide or two that you can look at towards the end. The talk that shows you some on-farm work we've done with this particular model and how it actually improved our water use efficiency when compared to just irrigating a straight rate or the way the farmer was irrigating in that particular year. So it shows that models like this actually have the potential to really help us increase yield, increase water use efficiency, and kind of be more precise with our water applications across the field spatially when we're making those applications. So it's actually showing validation of the variable rate irrigation technologies. And so we do have now on this farm at Midville, we have 2 pivots that have a variable rate irrigation system on them that we're going to start doing research with. This is the first year we're started, but we're hoping to move into the future to do more and more variable rate irrigation work here and matching that up to crop water requirements and in-season irrigation scheduling. So with that, got any questions, feel free to reach out to me. You can get my contact and we can talk a little bit further about some of the work that's being done here from the irrigation perspective.
I'm Philip Roberts, Extension Entomologist with primary responsibilities on cotton and soybean. I'm currently housed on the Tifton campus, but today we're standing in front of our plots at the Southeast Research and Education Center near Midville. Just want to make a few comments about cotton IPM. But IPM and managing insects in cotton, it begins with scouting. The only way we can make good decisions about how to manage insects and if we need to control them is to know what's in the field. So we encourage all our producers to hire a scout or take the time to scout and count these insects on your own. Now, with all of our commonly occurring insects, we do have economic thresholds established, and basically that threshold is a population of insects which will cause economic damage. So it is in your best interest to treat that pest population with an insecticide. Now, we really want to discourage just automatic applications of insecticides. We want all of our insecticide applications to be based on scouting and use of thresholds. And one of the reasons we want to do that is we want to make every effort to conserve beneficial insects. We've got a lot of different predator insects such as big-eyed bugs, minute pirate bugs. A lot of you are familiar with lady beetles, but we've got a lot of natural controls. Also parasitic wasps, which can help us by parasitizing some of our pest insects. But conservation of beneficial insects is really a building block where we want to, a building block for our entire insect management program in cotton or for any crop for that matter. I do just want to take a couple moments to also talk about probably our most common insect we deal with in cotton each year, and that's stink bugs or the stink bug complex. We actually have 2 primary species we see in cotton in the state of Georgia. One is the southern green stink bug, and the other species is the brown stink bug. Now, both of these stink bugs are bowl feeders. They actually feed on bowls that are about the diameter of a quarter. These bowls of this size are probably 12 to 14 days of age. But a stink bug has a needle-like mouth part. And what the stink bug will actually do is insert his mouth part into the developing bowl and probe inside the bowl looking for a developing seed. That's the actual target which the stink bug is trying to feed, is the seed inside the bowl. Now once a stink bug feeds on a bowl, a couple things may happen. Number one, you can just have physical injury to that seed, which will impact development of the lint. That can impact both the yield as well as the quality of those fibers. The other thing that can happen is a stink bug can introduce a pathogen, a bowl rot pathogen. And many of you have seen that when you're making decisions for defoliation late in the year. You're cutting bowls and you'll see bowls where a lock or several locks may, or even the entire bowl could be rotted due to this pathogen which was introduced by stink bugs. So we really want to make sure we scout all fields once we begin setting bowls. Our threshold for stink bug management changes by week of bloom. But to scout for stink bugs, we want to select bowls at random in a field, again about the diameter of a quarter, because that's where they prefer to feed. We will need to burst those bowls open between our thumb and forefinger, peel the outer carpal wall or the bowl wall away from the developing lint, and look for warts or callus growths or even stained lint. And that's what we would call it, that's when we know a bowl has been fed on by a stink bug, if we see these callus growths or warts on the inner surface of the bowl wall. And the decision to treat is based on a percentage of bowls sampled that exhibit this feeding injury. During the 3rd, 4th, and 5th week of bloom, our threshold is much lower than it is during the 5th or 6th week of bloom. And that's simply because during the 3rd, 4th, and 5th week of bloom, we have a much higher number of bowls on that plant which are susceptible to stink bugs. Okay, so when we get to the 5th, 6th, 7th, even 8th week of bloom, there's fewer number of bowls on that plant susceptible to stink bugs, so we can allow a higher percentage of feeding injury. It's also important when scouting stink bugs, you recognize what species are most common. Again, we're going to have either southern green stink bug or brown stink bug. Our pyrethroid insecticides do a great job on southern green stink bug, but tend to not do as well when we target the brown stink bug with the pyrethroid. To achieve good control of brown stink bugs, you'd need an organophosphate for control of that pest. Again, we need to protect cotton from stink bugs until the last harvestable bowl is approximately 25 days of age. And from that point, stink bug feeding on that bowl rarely causes economic damage once a bowl is 25 days of age. The second pest I'd like to talk about is corn earworm. And our studies here in Midville are looking at the different BT technologies and how they control corn earworm. So I'm standing in front of a trial where we're looking at these different BT technologies and basically just comparing efficacy. Now, one thing I would like to say about BT cottons, number one, BT cottons do an excellent job controlling tobacco budworm. They have since day one, okay? But corn earworm's a little bit of a different story. In recent years, we're seeing elevated levels of resistance in corn earworm to some of the BT toxins. Now, if you look back at the history of BT cottons, they were first commercialized in 1996. There was a single BT gene. Many of you remember Bollgard. Many of you remember a variety, Delta Pine 555 BR. That was the last single gene Bollgard that we planted on a large amount of acreage. Now, in time, following the introduction of the single gene BT cotton, our industry has added a second gene, and in more recent years, a third gene. And they did that for two reasons. Number one, if you think back to when we planted single gene BT cotton, it was not uncommon for us to treat a fall armyworm or to treat beet armyworm or to treat soybean looper when only a single BT gene was in the cotton. So addition of the second gene actually enhanced efficacy against some of these other caterpillar pests like beet armyworm and soybean looper. But the other important reason the second gene was added was for resistance management. It's getting another toxin in there, so you have two toxins working for you. But addition of the second gene also enhanced efficacy against corn earworm. And again, in recent years, they've introduced a third gene. And again, the primary reason there is for resistance management. Now, kind of where we are today in terms of efficacy of our Bt cottons, we do not plant single gene Bt cotton anymore. We plant a fair amount of 2-gene Bt cottons and a fair amount of 3-gene Bt cottons. But what you need to understand is that the first gene originally put into cotton 20 some odd years ago, corn earworm has developed resistance to that gene. And that's an important thing for us to remember. So if you have resistance to the first gene, our 2-gene cottons are basically functioning as a single gene cotton. And what we've seen to some degree in Georgia, but to a larger degree in other states across the cotton belt, is our 2-gene cottons, we're starting to have a lot more escaped corn earworm coming through those technologies compared to 5 years ago. We annually look at susceptibility in the state of Georgia. We know that we're resistant to the first gene. We have concerns that we're starting to see some slippage in the second gene with corn earworm. So the bottom line here is growers need to understand our risk for having problems with corn earworm on our 2-gene Bt cottons has gone up in recent years. Again, hire a scout. Make sure you're prepared to react if we run into a problem. Now to date, we would expect the risk on our 3-gene cottons to be much lower of having a problem, but again, we still need to scout. None of these technologies are immune to corn earworm attack. Now to scout for corn earworms in cotton, we typically start to see infestations once we begin to bloom. We encourage scouts to look at the top 12 inches of the plant for eggs, larvae, as well as damaged fruit. But more importantly, to look at a bloom tag bowl and be sure to pull the dried tag off the bowl and look under that tag for corn earworms. But also look at a small bowl and a bloom on that same plant. So it's a very methodical process to scout for corn earworm. If you see a corn earworm larvae that's approaching a 1/4 inch in length, it's very likely that larvae will survive. So our threshold is based on larvae that are at least 1/4 inch in length. With that, every year is going to be a challenge. We see different things. Just be sure you have a scout in the field. Make sure you use thresholds. Let's only use insecticides when absolutely necessary. Let's let our beneficial insects help us. And hopefully we'll finish this crop out and make a good crop and have a safe harvest.
I'm Mark Abney. I'm the peanut entomologist at University of Georgia. I'm here today at the Midville station. We're standing in front of some peanuts that were planted a little over a month ago. This is a lesser cornstalk borer trial. Last year when we had the field day here in Midville, if you were here, you remember it was hot and dry and there was a lot of lesser cornstalk borer all over the state, but especially in this southeastern part of Georgia. Talked with Anthony this spring. We decided we'd put in a lesser cornstalk borer trial here, and the objective of what we're doing in this field behind me is basically to look at new alternatives for lesser cornstalk borer management, tools that the grower can use in the field to manage the insect. So when you go into a field like this is early on. We tend to see lesser cornstalk borer problems when it's hot and dry. Okay, it's not hot and dry today, it's wet and it's kind of cool, but as I got here and talked to Anthony, it's been dry here and we've got lesser cornstalk borer in the state. Here we are on July the 8th, and I, for the last 2 weeks, have gotten a lot of calls about lesser cornstalk borer, and they're not just in one area of the state. They're in southwest Georgia, they're in south central Georgia, they're on the east side of Georgia. So we're set up right now for a potential problem later in August when the field day is actually going to occur. So we need to be thinking about, if it's August now, what's the situation in the field today? So if you haven't scouted your peanuts, I implore you to go out in the field and take a look and see if there's lesser cornstalk borer in the field. It wasn't that long ago when we didn't have good tools for lesser cornstalk borer management. The insect is difficult to control. It spends a lot of its time in the soil. When you spray a conventional foliar insecticide for lesser cornstalk borer, it's difficult to get contact with the insect in order to kill it. We now have a couple of foliar or spray tools, two different products that you can use that do a good job on lesser cornstalk borer. One of them is Prevathon, the other is Diamond. Either one of those products will give you good lesser cornstalk borer control. It doesn't have to rain to activate those products. That's really important. If you think back 5 years when you were putting granular Lorsban out for lesser cornstalk borer, it had to rain or that product wouldn't work. The other good thing about the foliar programs we have today is they don't flare secondary pests like Lorsban would do. So when you put a product like Prevathon or Diamond in the field, you don't have to worry about two-spotted spider mite or foliage feeding caterpillars coming in a couple weeks later because you put that product in the field. When we get into August and we're looking at insect pests in peanuts, there's a couple of things I want you to be looking for when you go in the field. One is foliage feeding caterpillars. We don't need to treat foliage feeding caterpillars if we're not at threshold. Our thresholds in Georgia are 4 to 8 caterpillars per row foot. We're talking about 1 foot. You have to have 4 to 8 caterpillars across the field to justify a foliar spray. But we don't want to let those get away from us. Last year in September, we had velvet bean caterpillar come in, and a lot of fields got defoliated because we weren't paying attention. We need to be looking for foliage feeding caterpillars in our peanuts in August. The other thing we want to be watching for in August is two-spotted spider mite. When Dr. Philip Roberts tells me that there's spider mites in cotton in June in Georgia, we need to be on the lookout for spider mites in late July and August in peanuts. If it's hot and dry in your area and you haven't scouted your peanuts lately, you need to be on the lookout for two-spotted spider mite. As of 2020, we have a new miticide. It's not new, but it's newly registered for use in peanuts. So we now have 2 true miticides that we can use in peanuts. One of them is Comite, the other is Portal. Portal is a really good miticide. You've probably used it in some other crops, and you need to look at it if you end up with mite problems in your peanuts. But we need to catch these problems early. Don't wait till the middle of September and find mites that have spread all over the field and then think you're going to control them, because once you get a really bad infestation, very difficult to control. Growers with irrigated peanuts, we don't usually see mites in here under the pivots, but those dry corners, you need to be watching those. If it turns out to be a dry summer, I'm going to warn you that the dry corners are going to be the spots where lesser cornstalk borers are going to be, two-spotted spider mites are going to be. That's going to increase your risk for seg2 and seg3 peanuts. So we may want to consider digging and harvesting those peanuts separate. It's really important that we can come here to Midville and do research on insect pests in peanuts. There's a lot of growers in this part of the state, and very often things are different here than they are in Tifton or Plains. And the only way we can evaluate what's really going on in this area of the state is to come here to Midville and be able to put research trials in. The staff here is really good. We're able to get our trials in. They take care of our peanuts for us. It's a long way to Tifton, and we don't have to bring all of our equipment here. It's really important. It's a really great place to work, and the information that we gather here is directly applicable to the growers here in southeast Georgia. So what I want you to take away from our talk today is it's August. If you're a peanut farmer, we need to be paying attention to what's going on in the field. It's the same message I give you every year, and that is walk your fields. There's no way to know what's going on in a peanut field if you're not in the field or you're not paying a professional scout to be out there. This is the time of the year when you can make mistakes that are going to cost you money, or you can make the right decision and keep money in your pocket. So go out, scout your peanuts. If you have any questions about pest management in peanut, be sure to contact your local University of Georgia County Extension agent.
Hello, I'm Peyton Sapp. I'm the County Extension Agent here in Burke County. Standing in front of our long-term cover crop study, I wanted to give you a little bit of background on the study here first. We started this really 3 years ago. It's set up to take a long-term look at cover crops and their impact in our corn, peanut, and cotton rotation here in the surrounding area. It's kind of, the implications are that we can better answer the questions that we've had from growers as county extension agents if we have a little bit of local data. In this study, of course, this year is our third year of the initial rotation, and it's planted to cotton, as you can see. And we have 4 different treatments, and they're replicated 4 times across the field to try to take into account variations in soil type, etc. But the treatments are a no cover block, of course, a rye cover block, rye clover, and then a mixed species cover. And again, those 4 treatments are replicated across the field. We had some startup help from Julia Gaskin, who was here in our sustainable ag position, Dr. Stanley Culpepper, and then a host of others now are becoming involved. So again, that's some of the background. You know, the initial grower questions that got us started were ranged tremendously. We got growers that have been doing this for 25 years or so, and you know, they're set in their system. But we know that it takes quite a period of time to get your cover crop system started, and you know, as we begin to work through other soil health practices that provide positive soil health benefits, we can see benefits, but we wanted to quantify it and measure it. So that's the gist of our study. We have taken, of course, yield data. We've taken nematode samples, routine soil samples. We are including soil carbon measurement, soil respiration, percent sand, silt, clay, and then again we're monitoring the soil moisture as well. So here at one of our mixed cover crop plots, we kind of want to go back to those guys that have been doing this cover crop thing for a while. They're all into mixed species cover, and see some of the benefits. Their goals match, you know, mixed species cover and what they bring to the table. We found that biomass, I would say, has been one of the top biomass producers here with the mixed cover species. We hear a lot about nematode suppression in mixed cover species because they're using brassicas and that. Would you say that followed what we found with nematode samples, or?
So as we started out this project in 2017 in the fall, after that cotton cash crop, we had high nematode populations, root knot nematode being one of those. But each year we have sampled immediately after the harvest of that cash crop. And even though we've seen some varying numbers with nematode populations, what we have seen mainly is its effect on the yield. Not necessarily by treatment that we see here, and when I say treatment, whether we're talking about the mixed cover or rye clover or conventional, it's the nematode populations within each plot and how that affected our yields.
So here in one of our rye clover blocks, you can see that there's quite a bit of biomass. And we're planting somewhere around 60 pounds of rye and 10 pounds of Dixie Crimson clover each season. We've built a really good biomass mat.
And as you can see, I mean, we're at 50 days after planting, and we still have a lot of good residue still on the ground, providing us good weed suppression.
I think one of the challenges we heard early on is that the fact that it may be hard to manage the rye clover cover. How do you get a good enough stand of each to complement? And I think we're doing that. And you know, again, this is long term, so we'll see.
And of course, the nitrogen credits that the clover is adding to this cash crop is pretty valuable in itself to be able to keep that in your mix.
That's right. So here at one of our rye cover crop blocks, we got what's classic here. Dr. Stanley Culpepper points out to me all the time that rolled rye takes the cake, he says, and true. It is a single species, maybe easy to manage, being a single species. It does give a lot of biomass. We find that to be true.
And for someone just starting in cover crops and using that type of system, like he said, it is an easier system to manage, and thinking about termination compared to your mixes. And you know, again, part of this project and this long-term study is to see what system is going to fit each grower. And a different system may fit in a different year for them on a different farm for a different crop. So that's all part of the mystery and what we're trying to figure out.
And that's right. One of the things you see, if you could see the whole each block here, this particular block is a little bit weaker. The cotton is, and I certainly don't attribute that to the rye, but our comments earlier about soil type and that kind of thing. It's not a one-size-fits-all business if you're going to start into a cover crop system.
And one of the things I always hear from growers is, how am I going to plant into that much residue? And we do stand counts here to try to measure, some of the issues that we face as far as planting into that kind of residue.
Certainly here at our long-term cover crop study, we hit a lot of points. I think the major take-home thing for us as agents in this area working with producers in cover crops is there's no one-size-fits-all. There's so much information out there, and what's going to work for you on your farm is going to have to be customized, starting with the particular cover crop mix and seeding rates and timing of planting it and getting it established all the way through to termination and how you handle that residue. So again, we're just encouraging people to learn like we are, take advantage, contact us if you have questions. And we'll try to give you any information you'd like regarding this study.
Hello, I'm Jason Mallard. I'm the agent from Scriven County, Georgia. As you've previously heard about the cover crop trial, the part I'm going to tell you about this is how we've overlaid on top of the cover crop trial and put an irrigation study in place on top of this, where we're going to quantify the benefits of cover crops as compared to irrigation and cover crop as far as water holding capacity and those type of things. What we've done is we've installed 11 trellis soil moisture sensors on top of this trial. We will be able to compare that in between the no cover compared to heavy cover crop and be able to look at it throughout the year and determine if we've had alterations of water holding capacity, soil infiltration rate, and so forth. Also, this irrigation system has been equipped through Briar Creek Soil and Water Conservation District with a variable rate irrigation system, where we'll be able to, in the future, as soil characteristics are altered by our cover crops, we'll be able to apply water at different rates and different needs as we go through the season. As of last year, being 2019, this program had been in place for 2 years. Prior to the 2019 year, we had 2 years of cover crops on this particular field, and we're keeping the same cover on the same plot each year. So we're building up certain areas while other areas are conventional tillage and so forth. We are, as with the 2019 year, only having 2 years of data, we did not see any alterations in the water holding capacity or the needs of the soil. So what we hope is, as soil organic matter builds during the upcoming years in the long term, we're able to see more water holding capacity and better infiltration rate, therefore reducing the water requirements needed on the farm. As we move forward into the coming years, we plan to be able, what we'd like to be able to do is quantify how much water savings we have, how much water conservation has been achieved, and the improved water holding capacity and so forth of the soil. And we hope to be able to present this to our farmers and be able to give them quantifiable information of what we've been able to do with adding cover crops to the fields.
Good morning. It's a pleasure to speak to you from University of Georgia Midville Farm. I want to tell you a little bit about our peanut research field. This is part of the research program of the Wild Peanut Lab, which is based in Athens, Georgia. And the aim of the research is to bring you cultivars of peanut that are more resistant against pests and diseases. Now, peanut, it's a great crop for the soils in Georgia. It produces a product of premium quality, and it makes money for the farmer but one of the things that really isn't ideal about peanut is that it's really susceptible to pests and diseases. Those pests and diseases, they're costly to control, they cost money from the farmer's pocket, and every tractor pass over the field is time spent and diesel burnt. So the aim of this research is to reduce those costs. The research program, if you were to summarize one word which it's all based on, it's genetic diversity. All of the peanuts that are grown in the world, they're just one species. But there are actually almost 100 species of wild peanut that grow in South America. Those wild peanuts, they have tremendously strong pest and disease resistances and some other traits that would be really useful to get into peanut cultivars. The trick is to get those traits in whilst maintaining the elite performance that the farmer expects. The way that we do that is that we cross the wild species with the cultivated species, then using cutting-edge genetics, which goes all the way back to the genome sequence, the DNA sequence, we go through generations of selection. Each of those generations maintains the very strong pest or disease resistance and increases the elite genetic background. Within this field we have a gradient. So over at the far side we have plants that are about 50% wild genetics. We can see they haven't grown as well within field conditions because they're really designed to grow in places like the savannas of Brazil. Progressing across the field to this part here, these plants are more than 95% elite genetics and less than 5% wild genetics. That 5% brings in pest and disease resistance. In particular here, a new source of resistance against root knot nematode, late leaf spot, and probably rust. All of this will be part of a genetic analysis which is done at the end of the season. And that's why we need to set up this scheme, this checkerboard scheme. The farm manager, Anthony Black, he's made these checkerboards using the tire tracks of a small tractor. That means within each square we can place 1 or 2 plants. Every single plant has an individual identification. It will be observed during the season, and selected ones will have their DNA observed at the end of the season, and in that way we will make our selections to take forward to next season. The whole process of hybridization selection takes many years, so we treat it like a pipeline and we're working along that pipeline the whole time. The plants over at that end, they're at least 5 years away from getting to something useful. These ones at this end of the pipeline are quite close. The cultivars that come from this part of the field here, we expect them to need less sprays and to be more robust in the field. That will save money and be more environmentally friendly.
Well, good morning. My name's Joe West, and I'm the Interim Dean for the University of Georgia's College of Agricultural and Environmental Sciences. And I'd like to welcome you to the virtual field day for the Southeast Research and Education Center in Midville. I hope we have a good day today together. You may remember me earlier. I served as Assistant Dean for a number of years for the UGA Tifton campus. And so I had the opportunity to interact with a lot of you over the years. I'm Interim Dean for a period of time. I wish our former Dean, Sam Perdue, the very best in his retirement. Sam retired at the end of June, has moved back home to North Carolina, and we just appreciate his service and wish him the best. And to give you an update on where the College of Ag stands as far as a dean, the University of Georgia is currently searching for the permanent dean for the College of Agricultural and Environmental Sciences. And in fact, in early August, we'll interview 4 candidates in hopes that we identify the permanent leader for this college, who will likely start in January of 2021. I've had the opportunity to interact with the Midville team for a number of years. You may recall that for several years I was administratively responsible for Midville and the Southeast Research and Education Center, and I've actually had the opportunity to watch it grow from being mothballed a number of years ago to bringing it back to life. In fact, Anthony Black and I started my former job on the same day. Anthony became superintendent, I became assistant dean, and so we had the opportunity to work together for a number of years. And I helped to bring Midville back to life, and it's obviously proven of value. Our research and education centers are crucial for the College of Ag and our scientists and for what we do. Our centers range all the way from the north in Blairsville to the south in Attapulgos, the west in Plains, and to the east here in Midville. And so they cover a wide variety of climatic conditions, of soil types, different conditions where we can test our practices, our genetics, whatever we need to do on a varied portfolio, you would say, of farms, so that when we recommend things to our industry, we have a high degree of confidence that it's accurate and that our farmers will benefit from those practices that we recommend. So we have a great opportunity to test. We have a great relationship here in Midville. We have excellent scientists doing excellent work, the staff, a great relationship with our county agents who are also doing applied research here. So overall, Midville has really proven to be of great value, and it was a great idea bringing it back to life. We're in a really strange time here in our country, in our world, with the challenges of the pandemic and then what it has caused from a budgetary standpoint. It has affected agriculture. It's affected our ability to produce food, to deliver food. And so it's interrupted our productivity in ways we never anticipated. For the University of Georgia and the College of Ag, we have our own challenges. We are working hard to try to reopen a university safely for our students, to provide safe work environments for our scientists and staff, and to be able to do those things that we need to do to provide for you as an industry. But I would assure you, the College of Ag and all our personnel are working very hard so that we can keep our people safe, we can get through these budgetary constraints and still deliver the kind of science, the research, the educational efforts that you've known us to deliver, and I can assure you we are working to do the same in the future. So my hat's off to the scientists you're going to hear from here today, from the county agents and the staff that are making it happen. And then one last comment, I really want to applaud Anthony Black and his team here at Midville. They do an outstanding job and support our people in a very great way. So thanks to them as well for all that they do. And now again, I hope you have a great virtual field day. Despite the fact that we can't be together, it's great that we have the technology to be able to deliver this, and I hope you find today very enlightening and educational.
Well, welcome. We're really excited to welcome you all to the Midville Field Days, which are a little different this year. Masks, I'm not in Midville, and there are no midges, no gnats, no anything flying around bothering me, which hardly even makes it a field day for most of us, right? But we're very excited to be able to present to you some of the research that's going on in Midville. You know, one of the best parts of my job is I get to see the diversity of research that goes on in the College of Agriculture. Everything from scientists investigating things, just trying to understand how the world works, all the way through to where we don't even know whether the results will end up in something immediately useful, all the way down to the sort of research that goes on in Midville where we're trying to find solutions to problems we have today. The work that goes on here is essential to the agricultural enterprise in the state of Georgia, and we're extremely proud of what goes on and the quality that comes out of here. So it's a wonderful opportunity for us to present that to you, allow you to see what's going on, and get the latest information of what we know that's going on in Midville. Now, one of the best parts of the college is we have research and education centers across the state. So Midville by itself is essential to our enterprise, but together with all the other research and education centers and the 3 experiment stations in Tiffin, Griffin, and Athens, we're able to cover all of the state of Georgia. So I hope you enjoy these presentations. I hope you learn something from them. And more than anything, I hope that if you have questions or comments or anything at all, please reach out and contact any of us, Anthony in Midville, me in Athens, or any of our extension specialists and researchers who are providing you with this information. Have a great time, enjoy the presentations, and I hope to see you next year without a mask in Midville. Thank you.
Hello, my name is Simerjeet Singh. I'm a UGA Precision Ag Specialist, and today I will be talking about our planter trial here in Midville, Georgia. We've been doing the planter trials here for the last 4 years now, looking at different planter settings in cotton and peanuts. Since we see there's a lot of proper setup, or things that can be considered while planting to ensure that we get the best stand possible. And that's why every year we have a study focusing on planter settings to see to kind of see the differences between incorrect and correct settings, but also to kind of test some parameters on the planter that we can get the research done and get some knowledge we can share with the growers on how to correct some of the mistakes they may be making every year while planting their cotton and peanuts. Last few years we've been doing a lot of downforce and depth studies, and our research has shown that you need to have a correct depth setting, but also you need to match that depth with the downforce setting to get the optimum seed placement. And we also seen some yield impact in both cotton and peanuts because of the incorrect settings, or I would say the lack of proper settings for the given planting conditions. And the correct depth and downforce also depends on different field conditions, whether it's a strip till, no-till, conventional tillage, or the soil type. So this year, kind of building upon the research we have done in the past, since there's a lot of interest in high-speed planting, plus every year we get a lot of weather challenges or other type of challenges in the planting season, so our planting window is getting narrower and narrower. And when these growers are trying to plant, they want to see if they can plant a little faster, or they're always trying to get more acres planted. So to answer some of those questions, this year our research here is focused on both cotton and peanuts with the speed by downforce study. The 3 different speed settings we chose for both cotton and peanuts were 3 miles, which is kind of, I would say, a nominal planting speed that most of the growers utilize, anywhere from 3 to 4 miles. So we want one of our treatments to be on the low side. Then we have a 5 miles per hour that some of the growers are also edging towards on the higher side of that 4.5, and almost getting 5 miles. And then one of the high speeds we have was a 7 miles. Now, when I see high-speed planting, we didn't test. First year, we only want to focus on a traditional planter system with a ground wheel drive and mechanical system. In the year forward, we also want to test some of the technologically advanced planters to see if we can achieve a high performance, a good planting performance with high-speed planters. So this year we planted everything. We had those 3 treatments, 3, 5, and 7 miles, and our downforce was no downforce, which typically in cotton you wouldn't need anything with a 1-inch seed depth. A low, medium, and high. The 0 was our low, no downforce, and 100 and a 200 pounds in cotton. And then in peanuts, we were 0 and a 200 and a 400. And the reason for a little bit higher downforce in the peanuts was you need a little bit extra to go to plant that seed deeper at about 2.5 inches deep. So in peanuts, we try to shoot for about 2 inches, but we were a little shallower than that. So those trials were implemented in long strips where we maintained 1 speed strip and a downforce in each of the trials, and we replicated it throughout. And after we planted, right after we planted, we start checking emergence. Our first emergence in both the trials start coming up at about 5 days after planting. So we started our data collection at 5 days. We did it 5, 7, 9, 14, and our peanut emergence was a little late, so we also did one additional at 16. And at those days, we concluded that that was the final emergence. We also checked seed depth in both of these trials to make sure that we were how the speed and the downforce affected our treatments. And then we also did the spacing because seed depth, like I said earlier, is mostly influenced by the downforce. If you have a more, you're tended to plant a little deeper. But also at higher speeds, you would need a little bit more downforce for the planter to be more stable. So for the speed effect, we also looked at the plant spacing. As more and more research is coming out of the row crop, especially corn, we're also evaluating that in cotton and peanuts, that does plant spacing really matters. And some of the early research has shown that if you have a uniformly spaced plants, you potentially maximize your yield potential early in the season versus a non-uniform spacing right after planting. So we collected those 3 data sets: crop emergence, seed depth, and plant spacing. And we also going to evaluate the yield when we harvest these towards the end of this year. So I have some of that data analyzed, and initially what we can see overall, looking at the effect of speed and downforce, we didn't find any interaction between the speed and downforce in any of our trials. Overall, our emergence was about 80 to 85% for all 3 downforces, so there was no effect between the downforces on the emergence. However, we did see a decreased emergence at a higher speed of 7 miles per hour, and that kind of will explain some of the data on the depth and spacing that I will show earlier. So from the seed depth data, what we noticed that our target seeding depth was around 1 inches, and we did about anywhere from 4 to 8 different samples within each plot to measure the seed depth. And our seed depth varied anywhere from 1/2 inch to 1.5 inches. So that kind of explains the variability because of the different downforces and the speed you can have using the same settings. So for all the settings, there was variability anywhere from 1/2 inch seeding depth to 1.5 inch seeding depth, and we didn't see any significant differences, just large variability between all 3 treatments. From our spacing data, we calculated the mean spacing, but we were also interested in if the planter was able to maintain the plant singulation, seed singulation while planting. So we calculated the number of skips and multiples that you would expect at different treatments, and our initial data shows that we had the most uniform seed spacing at 3 miles per hour, and it got a little worse at 5 and then a lot worse at 7, which was kind of expected because as you are driving faster, your meter has to spin faster and do its job at the same at that higher speed to maintain that singulation, and it cannot maintain the same singulation. So our CV numbers, which is how well the meter maintained the spacing, was anywhere from 20 to 30%, with some of those higher 30% numbers more on the higher speed side. And we also noticed that there were more skips in cotton. Talking about cotton, there were more skips in cotton at the higher speed, which means, again, it was not able to plant the seeds at the desired spacing as we increased the speed. We didn't see any downforce effect on the seed spacing in the cotton. In peanuts, we collected the same data, and on the emergence, compared to cotton, our peanut emergence was pretty low, with an average of anywhere from 40 to 60%. And there was a significant difference in the emergence between the lowest downforce and the 200 and the 400, which kind of explains that because we're, like I mentioned earlier, for peanuts, for planting at 2 inches, you need a little bit extra downforce. So as we used 200 or 400, we see a little improved emergence, anywhere from 35 to 40% overall, compared to when we had no additional downforce. Our emergence was about 30% and was statistically different from the others. So you do need a little bit heavy downforce when you're planting peanuts in that. Speed, we also noticed the effect of speed on emergence, where our emergence reduced significantly as we increased speed in peanuts. We went from 50% emergence at 3 miles per hour to 18% emergence at 7 miles per hour. So that kind of tells you that we were not just doing a poor job of singulating, but it was also affecting the overall emergence. Looking at the seed depth data for peanuts, we had some large variability as we noticed in cotton. However, the variations were even larger. So our seed depth for all the treatments across was anywhere from 1/2 inch to 2 inch. Most of them, we were targeting our target seeding depth of 2 inches, but our data suggests that we were anywhere from 1/2 inch up to 2 inch, a large variation for all the treatments across. There were some significant differences, but prelim data shows that most of the larger variability was observed at no downforce, where we didn't have enough downforce to put that seed deep down. When we looked at our spacing, our mean spacing, we were putting about 6 seeds to the foot, so 2-inch spacing in peanuts. Our mean spacing increased with speed, which was kind of expected, and our CV numbers were also higher as we increased the speed. Something to really make a note of here, compared to about 20 to 25% skips in cotton, we see a really high number of skips in peanuts, anywhere from 50 to 60%, and that will also explain why there was such a low emergence in peanuts, anywhere from 40 to 60%, because we had a really high number of skips. Now, the skips we counted from plant spacing also accounts for the plants that didn't emerge, but we also saw a trend that as we increased our speed, that our number of skips increased. So speed was affecting our meter performance in singulating that seed as we went higher on the meter speed. We didn't see any effect of downforce on the plant spacing, which was kind of expected there. But overall, these results again kind of shows that as you increase the planting speed, you're gonna do a poor job of singulating that speed. It's gonna affect your seeding depth, and it's also gonna affect your singulation and plant spacing. And other thing the trial kind of emphasizes that if you do plant at a little bit higher speed, depending on the type of soil conditions you're on, you may want to increase the downforce a little bit. Even though we didn't see any significant differences in trial, we still have to evaluate the yield component, but it's usually recommended because of the planter's ability to be more stable at a higher downforce, especially at higher downforces speeds. So you do want to up the downforce a little bit at a higher speed to keep the planter stable and minimize any row unit vibrations. We will at the season end evaluate the yield for each of these treatments at the end of this year and have that data compiled all together, and we'll share that knowledge back with our growers in our county meetings and also in our cotton production workshop, and also at the Peanut Farm Show in Tifton beginning of next year. All right, so to wrap up, again, that was all the results I have for today to discuss and show those. I really want to thank you for listening to the field day virtually, and also I want to thank the Georgia Cotton Commission and Georgia Peanut Commission for sponsoring these research, so we can actually do this sort of research on the farms out here and able to provide useful information back to the growers out of the research. Thank you.
Hello, I'm Scott Mumford, the Extension Peanut Agronomist for the University of Georgia. Glad that you can be with us for this virtual field day here at the Midville Research and Education Center. And I want to talk to you about a couple of things. One, about the project that we've been working here on the Midville site in regards to peanut and tillage practices. That's one thing I want to cover, and then I'm going to mention just a few things about the crop, a few things for growers to keep in mind as we go into the rest of this season that might help you out a little bit. So let's start with the research project that we've been working on. We've been very blessed in the fact that we have this research center here in Midville to help answer questions for this area. And one that come about in a production meeting was, what about tillage practices? In East Georgia, particularly this area, highly erodible land, can we reduce our tillage practices in order to conserve and not have, problems with washes or causing problems in the field? Can we back off on our tillage practices and still be economical? And so, luckily, we have the room here on the Midville Research Center here that we could put in large-scale tillage-type trials. And Anthony did that for us, and this is going on the third year where we've been comparing conventional deep tillage where we're bottom plowing compared to a just ripping bed reduced tillage practice versus compared to also a even more reduced till of just going in with a chisel plow, which is not something I would necessarily recommend. But we wanted to have kind of the low end also to look at and compare to what we call a reduced tillage practice where we go in and rip in bed. So that's kind of the basis of this project here that we've got on the Midville site. And today you can't really see any differences, but I tell you, every year when we get the yield back and the grades back, we are seeing very good research data there, and it does support that right now the people in this area are remaining to be economical by going to that reduced tillage practice, and it's helping them on the farm. Well, guess what? They're not losing a lot of yield. We know we get better yields with our deep tillage, but if you save a lot on time in the field, fuel, and labor, then guess what? It's a wash. As long as we can be sustainable in our fields in this area with that reduced tillage practice, right now it looks pretty good that we're doing the right stuff. So I'm pretty happy about that. We're going to continue this project to gather more data, so I'm glad of that. The last thing that I wanted just to talk with you a little bit about is the crop. I always talk about the crop when I'm at the field day. We've had a lot of bumps and bruises to begin this year. Most of you guys are well aware of that. We had unseasonably cool temperatures all the way through the mid part of May. We had a lot of wet problems, too much moisture. Then we also had dry problems. So, being too dry and couldn't really get in and plant. So it's been kind of crazy. And then on top of that, we got thrown another curveball with seed quality issues. And so we have fought and fought and fought to get this crop where it is today. Right now, I think we're in good shape. Everybody's got a stand for the most part. That's growing. We're getting plenty of moisture at this point. Hope it'll continue throughout August. And if it does, hey, guess what? I think we'll be in very good shape for this crop to be high yielding and good quality. Now, one thing to remember as we go through this, please take care of your pest problems, your disease, and all that. Don't try to cut corners. Let's make sure we keep this crop moving in the right direction. Now, when we get to the first part of September and we start thinking about maturity, remember, go back and try to pull your situation at planting back up and understand whether or not you had to go in and replant or whether or not you had great stands to begin with, because that's going to change a little bit of how we approach this maturity. If you didn't have any problems, guess what? You're perfect. But if you had problems getting those plants up, it might have took you about 3 weeks to see them all come up, or you might have had to go in and supplement seed to get up more plants to have a good stand. All of that's going to play a role in the maturity of this crop. Make sure that your county agent knows that, because when he puts them on the board, understanding whether or not you went in and replanted or added more seed, to get more plants up, that will help him determine your maturity. So please do that. Please remember what kind of problems you had in the field, but also let them know if you're having any problems at the point of time that you pull that sample. If you do all that, I think we can dial this thing in, as far as maturity goes, to help you get that crop out when we need to. So just a few things to think about. Remember that we're just a call away. Let us know if we can help in any way. If you see something weird in your field, you need help, call your county agent. They'll get us out and help out as much as possible. With that, I appreciate your time.
Hello, my name is Corey Bryant. I am the UGA Extension Grains Agronomist, specializing in corn, soybean, and small grains production. And today I am here to talk to you about the Midville large-scale corn hybrid trial that has been going on for, this will be the 5th year. Just talk to you some about the yields of the different hybrids and the management of the trial. So in the hybrids in the trial are AgriGold A6544, V72 Pro, AgriGold A6659 VT2 Pro, Pioneer P1870 YHR, Cropland CP5340 VTP2, Cropland CP5678 VT2P, Decab 6869 and Decab 6916, Dynagro DG58 VC65, and Terrell 28 BHR18 and Terrell 28 R10. So for these hybrids tested, this is a large scale study replicating how corn would be grown on your farm. The purpose of this trial is to compare all these different hybrids under similar or the same management practices. So these management practices are shooting for a yield goal of 250 bushels, and all fertilizer, planting, irrigation management decisions are based upon current UGA recommendations. So just a quick overview on each of the varieties through the duration of this trial. All of the hybrids selected have shown strong disease resistant traits, and now we have sprayed these trials for southern corn rust in all years. It is an irrigated trial. We provided with overhead through a lateral system. Fertility of this trial, pre-plant fertilizer, 60 pounds nitrogen, 150 pounds phosphorus, 250 pounds potassium, 39 pounds of nitrogen and 43 pounds of phosphorus as starter with planting in a 2x2. Then 114 pounds of nitrogen side dressed as UAN at the V5 growth stage. And then another 114 pounds of nitrogen side dressed as UAN at the V8 growth stage. And then irrigation is based on UGA requirements. In the last year of the trial, it had 11 inches of irrigation, which was last year. So to get into the yield real quick, the top 3 performing hybrids in this trial on a 3-year average was the Agrigold A6659 with an average of 266.57 bushels, followed by Cropland GC5678 with 250 bushels, and Terrell 28R10 with 248 bushels. Then below that, for our across the other varieties, based on last year's data, which last year's data is down compared to previous years due to some field drainage issues and issues in the field beyond our control. But our top yielding varieties for last year were our Dynagrows, 57 VP51 and 58 VC37, both with 180 bushels, followed by our Decab 6595 at 175 bushels, the Agrigold A6659 and A6470 with 173 and 165 bushels. Then our Decab 7027 at 163 bushels, Terrell 28R10 with 158, and our Pioneer 1197 and 1870 at 150 and 147 bushels, followed by our Cropland 5678 at 125 bushels. Now again, don't take last year's number on their own. There were management issues that significantly reduced those numbers. And so if we look the past 3-year average, again, the Agrigold 6659, Cropland CG 5678, and Terrell 28R10 were our top 3 yielding hybrids for this region under these management conditions. So as far as the hybrids and individual traits of each one, through the course of this study, our Pioneer hybrids have been our tallest, with a medium ear placement, and the cropland hybrids have been our shorter hybrids, but have still maintained a good ear placement and height. And the remaining hybrids have been in between in regards to plant height and ear placement. Ear placement across all of the hybrids has been fairly uniform. All hybrids have a good ear placement, which will make for ease of harvest and a good harvest efficiency. So that is a quick overview of the Midville corn hybrid trial. If you have any further questions, you may reach me by email, and I will answer any questions you may have.
Yeah, good morning, and it's great to be here. Thanks Anthony Black for such arrangement. My name is Zhenglu Li. I'm a professor and a soybean breeder in the Department of Crop and Soil Sciences at the University of Georgia in Athens. Today, I'm going to talk about the soybean breeding work for the drought tolerance, also along with my PhD student, Ethan Mackey. And as we know that the soybean is one of the important oilseed crop in the world, with the use as vegetable oils and as a protein source for the animal feeding, also as biodiesel and many types of soybean food. So the soybean is the second largest crop in the US. As we know that the drought is abiotic stress. It is threatening the agricultural productivity of the soybean, also for other crop as well. So it's really cause a yield loss. It can cause a yield loss up to 40% in the crop season. And as we know that back to 2012, due to the drought and the soybean yield or other crops yield as well, lost up to 20% nationally. It's a big loss. So right now, and we think that maybe most people think, oh, we can do the irrigation, but the irrigation is expensive. It may not be a good approach, a practical approach for most of the soybean growing region because the cost and the operation as well. So we think that to develop the soybean cultivars with the drought tolerance, maybe that's the best practice. So that gave the soybean growth and the production and such drought stress. So we work on the soybean breeding work. I think try to develop the soybean cultivar with the sort of the drought tolerance for soybean growth. And the United Soybean Board and recognize that's such a challenge, organize a national team to work on the soybean breeding work for drought tolerance. So UG soybean breeding program is a part of that national team and supported by United Soybean Board to work on the soybean breeding for drought tolerance. The main goal is we want to identify the soybean germ plant lines with the trait. We talk about the drought tolerance trait, like canopy wilting, the other trait as well, relate to the drought tolerance. And also we want to identify the new genes, all the genes, new genes, and responsible for the drought tolerance. So we can integrate those genes into our elated germplasm for the cultivar development with the drought tolerance trait. Okay, so that's the kind of goal we have that is supported by Check-Out Fund and by United Soybean Board. I really appreciate that. And based on that, Dr. Roger Boermer is my predecessor. He then worked in this area, soybean breeding genetics, for many years. He laid a great foundation. We can continue that and the foundation, continue that work for our soybean breeding work. We have identified some, we have utilized that information and to incorporate that and in the soybean breeding program, develop the soybean lines with the drought tolerance trait in the pedigree, very promising. Meantime, we have identified some of the lines have the drought tolerance, slow canopy wilting. In the process to identify additional genes, novel genes for such a tolerance. Also, we want to integrate the new genes into the elated germplasm lines for the cultivar development. So that's the process. And UG have a very strong soybean breeding program, and we have developed a strong pipeline of the soybean breeding materials with the conventional, also herbicide tolerance trait like glyphosate, Liberty Link, and also recently we work on Enlist and Roundup to extend and as well. So this is the pipeline. Also, thus we also incorporate that disease and the pest resistance into those elite line as well. So we have a very strong pipeline. And the meantime, we want to evaluate those lines. We developed that for the drought tolerance. We can see from this field, those lines are advanced line from the soybean breeding program. Those lines have been yield tested in multiple locations in the regional test, like a USDA Southern Uniform test or the state variety test conducted by Georgia, Alabama, and South Carolina. We want to evaluate the yield performance across this southeast region. And in this field, we want to look at that and drought tolerance for those advanced line. Basically, we want to look at that canopy wilting trait. If any lines have a slow canopy wilting trait, we can have some of the indication for the drought tolerance. That's the reason we want to evaluate that and this field. So ongoing basis, we want to use the new technology like drone and to take the image in the field. We can tell that which line have a slow wilting and high, fast wilting, canopy wilting. Ethan Mickey will talk about that and follow up. So that's kind of our ongoing research work. And I want to use this opportunity to thank Anthony Black and from Midville Research and Education Center for his great work, great support. I want to take this opportunity to thank Anthony Black from Midville Research and Education Center for his great work and great support to our research in Midville. I also want to take this opportunity to thank our funding support and the United Soybean Board and the Georgia Soybean Commission and the University of Georgia Research Foundation for their funding support. I really appreciate that funding support. Also, I want to thank Georgia Seed Development for their plant breeding equipment support. And without that support, we cannot do the research. I really appreciate all their funding support. Also, thanks the soybean breeding lab and the research, the graduate student and the staff for their work. Also, thanks the collaborators to our research as well.
Hi, my name is Ethan Minke. I'm a PhD candidate at the University of Georgia. I work under Dr. Lee, the soybean breeder in Athens. And I'm here today to kind of explain how our program is using new high throughput methodology in our pursuit of breeding a better drought tolerant soybean variety. As Dr. Lee said earlier, especially in these plots behind me, we're really focused on evaluating these soybean varieties for canopy wilting and that slow wilting trait, which we have assessed with that drought tolerance and yield protection. Traditionally, how you would phenotype that trait is you come out in the middle of August and September in the middle of the reproductive phase of the soybean when it's setting grain during the middle of the day when it's as hot as possible under drought conditions, and you would rate those soybeans for their difference in wilting. This is a 1 to 100 scale. It's difficult to do. You have to do it, as I said, in the middle of the day when it's really hot. It takes a trained person, and it's kind of a time-consuming process to come out here and do that and get through a field in an entire day. But it has yielded good results. Our job in our program is to not just breed for drought tolerance, but to be more efficient and use our resources better and use the resources we have in the best way possible. And so one of the ways we've done that is through the use of new high throughput phenotyping technologies. And all that is we're just trying to find new methods of taking that same measurement we were, say, canopy wilting, but with something such as a drone, which we can use and cover a lot more of our plots than, say, what I can come out and rate in a day, when it might take me 3 hours to phenotype the field behind me with a ground-based measurement or me just taking notes. I can do the same process within about 20 minutes with this drone. So that's one of the ways we're trying to be more efficient. And how that technology works is our drone, unlike your camera on your cell phone, sees an additional color. So your camera on your phone sees blue, green, and red. Our drone sees the NIR, which you can't see to the naked eye, but if you've ever been outside under the sun and you feel that warmth from the sunlight, that's NIR like making you feel that. And it happens the same way on a soybean. And healthy soybeans have the ability to reflect that and they don't absorb that heat. So our goal with this project is to associate that reflectance of NIR light with that slow wilting trait with the hopes that instead of having to come out here and rate our soybean plots by hand, we can do it by a drone picture, which is a lot faster and a lot easier. And I can figure out how my soybeans are responding to drought sitting in my office with a picture instead of having to stand out here under the heat. Our end goal is to pick a high yielding soybean variety for producers to plant in their field to be the most productive and produce the most soybeans that they can with the limited resources that they have. Again, I would like to thank Dr. Lee for giving the opportunity to talk today, and Anthony Black and the Midville Research Station for supporting our efforts down here and taking care of these plots and helping us out in anything we need. Thank you.
Hello again, I'm Jason Mallard, agent from Scriven County. This time I'll talk to you about the 2020 cotton variety trial here at Midville. At Midville, the purpose of this project is to give us side-by-side comparisons of the different varieties that are the newest varieties on the market at this time. Here at Midville, we do have an irrigated trial and a dryland trial. Both of these are designed for multiple repetitions of each variety so that we take out any variation such as soil type, we take out variation of rainfall in different areas and so forth by repeating these 4 times over these fields. We, across the state of Georgia, we have 29, I believe it is, of these trials that are repeated across the state, giving us to be able to cover across the state and how it is in different areas. Also, in this trial, we have 12 varieties this year. This is constantly evolving. If we look back to the year 2016, there was 1 variety that was in that trial that is still currently being tested today, but each of the others have revolved out. When we look at last year's trial, we had 5 that were brought forward to this year. As we move into this year now, we have 7 new varieties that are being brought into the trial, new from this year's new varieties. It is important as we start to evolve and bring new varieties onto our farm that we are looking at multiple years data, and also we need to be sure that we make slow adjustments into the varieties in our farm so that we don't end up going too fast into making changes. When we take into consideration the ones that we have this year, we have 2 wide strike 2 varieties in this trial. We have 1 Beauregard 1, we have 8 Beauregard 3 varieties, 1 Twin Link Plus, and also as far as looking at the trial this year overall, looking at all the varieties that we have in it, we have 3 Delta Pine, 2 Next Gen, 2 Phytogen, 2 Stoneville, 1 Cropland, and 2 Dynagrow varieties. I hope this year we can end up getting some good data out of this trial, and if I can answer any questions related to this trial, don't hesitate to call me. Thank you.
Hi, I'm Pam Sapp with the Jefferson County Extension Office. As a cooperator with the annual cotton variety trial across the state, one thing we feel is very important is the multi-year data that we can collect from these different varieties. Every situation and every field is different, and having so many locations across the state with varying soil types, weather conditions certainly helps in giving the big picture of what varieties may be more suitable for you on your farm. Again, every farm is different, every field is different, so you don't want to plant all of your farm and all of your fields to just one variety, and having this one other tool in your toolbox to make these selections is very helpful. Granted, we bring in new varieties each year, the newest things on the market. However, we do try to keep some of the same ones around from year to year, just as comparisons, and see what's steadfast from year to year. Variety selection is not a game, and it can be the difference between a profitable year or not. And new varieties are great, but limit their use in those fields, as they're warranted. As behind us here, we have the 2020 variety trial, and of course we'll be giving you the data from those yields at our winter production meetings, hopefully. And but as far as a recap from 2019, those on-farm variety trials, we had all good varieties. I mean, these were all top producing varieties. If you look from the top to the bottom across all 25 locations, you're only looking at about 180 pounds of difference in lint yield between those varieties. Some of the things that just pop out amongst those yields is Dynagrow 3615, for example, was in the top 3 60% of the time across all those locations amongst those 11 varieties. Delta Pine 1646 was among the top 3 52% of the time. And then we had what was a trial variety last year, a Phytogen PX3 B07, which is now labeled as Phytogen 400. It ranked in the top 3 36% of the time. Stoneville 5471 was in that top 3 across those locations 24% of the time. And again, all of these being really, really top producing variety. So we're excited to see what this year is going to hold for us, banning any hurricanes that we had a couple of years ago. The crop looks really good right now, so hope to have some good data to come out of this.
Hello, I am Stephen Powell, Trutland A&R agent. Each year, cotton growers are faced with many production and management decisions. Researchers at UGA have developed tools in order to help make those decisions more profitable for cotton growers. However, many Georgia cotton growers are found to use practices as opposed to the UGA recommendations, which leads to two questions. One, why are cotton growers using management methods other than the UGA method? And two, is the UGA method economically valid in maintaining profitability and sustainability for cotton growers? In 2018, former UGA agronomist Mark Freeman and Jared Whitaker, along with Wes Porter, precision ag specialist, began a cotton systems trial at the UGA farm in Midville. This trial consisted of 3 different management practices. 1, a low input practice. 2, the UGA recommendation practice. And 3, a high input method. These recommendations were based on seeding rate, irrigation, plant and disease control, along with growth regulators.
I'm Savannah Tanner. I'm the county agent in Emanuel County, and so I, with Stephen, am working with several county agents on the cotton systems management trial. What we found within these trials is that when analyzed with inputs that we used from each individual system, both the low input, the high input, and the UGA recommendations, when analyzed at a loan rate, the low input system was the most profitable within those 2 years, from 2018 and 2019. But when analyzed at a market price, the high input system was more profitable over the past 2 years. So what we find and conclude is that cotton prices play a significant role in the optimal level of inputs in order to maximize profit. So as cotton prices change, our management structures and systems should also change. We expect to find very similar data here in 2020, even with some reduced cotton prices as a whole. So we look forward to seeing that data and information. For this systems trial, we want to thank all of our county agents that are heavily involved in it from multiple counties in Southeast District Extension, the Georgia Cotton Commission, Cotton Incorporated, Anthony Black, our superintendent here at the Southeast Georgia Research Center, Travis Woodard, who's also employed here, all the UGA cotton team members, and then again especially Wes Porter, who is kind of leading our systems trial here at the Midville Research Center.
Hello everyone, I'm Henry Sintim and I'm based over at the University of Georgia Tifton campus. I'm the soil fertility specialist. I have 60% research and 40% extension responsibility. My primary area is in soil fertility. As you are very conversant with the conditions we have here in Georgia, our soils are very highly weathered. So it takes a lot of intensive management to get that done. But my primary focus is into row crops. I'm primarily looking at corn, cotton, peanut. I do soybean, and I have some sorghum plots too. So for where I am here, you are seeing the cotton study. It's actually proudly sponsored by the Georgia Cotton Commission. It's a 2-study kind of project. The first one, we are looking at how do we move the yield margin of cotton. Most of producers or even the University of Georgia current fertility recommendation have yield recommendations for up to 3 bills. But producers have been wondering, could we move that margin even higher? And previous studies done by Dr. Glenn Harris shows that indeed we can move yield margin a bit higher. He looked at profitability for the up to 3 bills, and the return on investment were all positive. So there is that potential for doing that. But in order to really get down to it, we need to understand the nutrient uptake dynamics in cotton. So we have, this is a multi-location study. We have some going on in Camilla. We have also on producer fields in Brooks County. We also have here. So it's looking at various how location and climate all play into the fertility. And what we are doing is we are deliberately inducing 3 different stress principles on the crop. The first is we don't provide any nutrient at all, no, neither primary or micro or secondary nutrients to the crop for up to the first initiation of square, the pinhead square. We are looking at how the plants will tolerate these nutrients, and then after we come in and do a complete nutrient recommendation to those crops, and we partition the crop. We look at the nutrient uptake over time in the leaves, in the stems, and then also in the reproductive tissues. And by that, we are able to have a better understanding of nutrient, how the crop is partitioning the crop nutrient. And like I said, the first stress is we did not apply any nutrient. The other one is we only applied 30% of the recommended rate to the crop at planting, initial phase of planting, and we did not do anything at all to the crop. By that, what we are doing is we would see how the crop responds to nutrient uptake, and then we expect it to undergo nutrient deficiency down the line in the season. Since we are doing tissue, we are partitioning the plant tissues, we are able to tell which part of the crop responds to nutrient deficiency quicker. By that, producers would be able to know how the best diagnostic test for cotton, because yes, it starts out sufficient, but we deliberately put out only 30%. So down the line in the later season, and cotton is very good at hitting you bad on nutrient deficiency down the line during the late season. So and the other one is dynamic nutrient management, where we take tissue analysis, look at which nutrients are deficient, and then supply the nutrient as needed. In that, the standard recommendation for 3 bales is what we used, and we have another, not for the producer field and the study here, but for other studies in Camilla and other places. We have another one where we are looking at the potential to increase the yield goal to 4 bales, and preliminary results show it's promising. You can clearly see differences in nutrient levels, and so that to me is exciting. And we are still, this is my first year. We are looking forward to the data, and we would be sharing to you all to various platforms. Make sure so watch out for it through extensive publications, meetings, and trainings, webinars. So there would be so many platforms that we will use to communicate the results, even like this, having field days, virtual field days, video recording. We are going to make sure as the results become available, we will share with you. So like I said, the other aspect of the study is a soil health study. And as I already mentioned, our soils here are highly worded, and so we need to do an intensive management of our nutrient. If we can improve our soils, that would make our soils more forgiving. That is the goal. How do we build up the soil? And my principle that I'm working with is that the various management practices that is known to help improve your soil, like cover crop, like tillage, minimum tillage, or any form of conservation tillage, organic amendment. My principle has been that if you can integrate all these regenerative practices, all these different bits and pieces are called regenerative agricultural practices. If you can integrate them in a system, in a sustainable system, you begin to see impact on soil health in a much quicker, and it become more effective. The school of thought, the old schools of thought is soil fertility. It takes so long to improve your soil health, but is that truly the case? Maybe not. And so that is the goal of the study. We have different treatments looking at just only cover crop, we are looking at only reduced tillage, and then there is a combination of both of them where we have organic amendments. We are amending the soils with animal manure, and we have biochar, and then we also use commercial microorganisms to inoculate the soils to boost biology of the soil. So, and these are, like I said, have been integrated there, and we are going to see whether the soil absorption of individual practices or a combination of these regenerative practices helps improve the soil. This is the first year. My goal is to keep that study going for the long term, because we think that for the soils in Georgia, the way to go is adopting regenerative agricultural practices that will improve the soil. It's going to help. Yeah, basically that's what we have ongoing as far as what I'm doing for with regards to cotton project. Thank you.
Welcome once again to the Southeast Georgia Research and Education Center in Midville, Georgia. I'm glad you're here. I wish we could be here in person. It's always a great day when we have this field day, but I'm glad that we can be out here in some way, fashion, form, or another. I think it's really important. You know, this is Georgia. You can see from me, I've just finished spraying plots. It's going to be hot. It's going to be humid. I'm going to be hot and tired. But the work we do in Midville, we can't do anywhere else. I also work at other experiment stations, but what we do here in East Georgia in the Midville station really serves the growers in this area. And why is that? It serves the area for a lot of different things. I work with corn, I work with cotton, I work with soybeans, I work with peanuts. There's several reasons. First reason is that your soil is different. Your nematodes are different. Your soil diseases are different. Second thing is we can expect different growth patterns that we have to look at. Third thing is some of the diseases we see on cotton, which may be very severe, like target spot, in southwest Georgia, may not be quite so severe here. And most importantly, when we look at corn and we look at soybean, diseases like soybean rust and southern corn rust, which start in the southwest corner of the state, we need to be here to see when they get here. So because you are different, you're still hot, you're still humid, but we still have a significant disease and nematode problem, and we need to have the chance and the opportunity to look at it. On the experiment station here, and I want to compliment our staff, Anthony, and all who work for him. It's an excellent staff. We're able to get answers for the growers in this area that we're not able to get other places. I also want to thank the administration for keeping us here, keeping the support here, and also that would not be possible without our commissions, the Corn Commission, Soybean Commission, Peanut Commission, Cotton Commission, and the growers in this area. So here at Midville, I cover 4 different crops. First one I'm going to talk about is peanuts, and the peanuts plots are behind me. I've been spraying them today, as you can probably tell. I hope I don't pass out when I'm talking to you. But what we're looking at here is different fungicide studies. We're looking at the importance of timing of fungicides and some of our newer fungicides we're putting out here. Replicated studies. We're looking at the most modern fungicides that are coming out, and we're also looking at the timing of those applications. While we're here looking at these diseases, we're looking at what the importance of the management is, different fungicides and different diseases. And what you see behind me are 2 different fungicide studies looking at new fungicides compared against our traditional fungicides. We're looking at the management of leaf spot, we're looking at the management of spotted wilt, the management of white mold, and the management of other diseases as well, to include Aspergillus crown rot. We get this data because it complements our statewide trials, but it also gives local data to our growers in this area. And we can't get that unless we're out here up in a place like Midville. We've stepped away from my peanut plots and now we're looking at cotton. Typically we've looked at diseases like target spot up here, areola mildew. We've also looked at the Columbia lance nematodes, but this year we're looking at something different. There's a new disease of cotton to Georgia and the southeastern United States, at least newly recognized, and that is cotton leaf roll dwarf virus. And on the station this year, we have sentinel plots where we're looking at different varieties and coming in and taking aphid counts. The cotton leaf roll dwarf virus is vectored, it's spread by aphids. We're taking aphid counts, and we're also watching for the development of the cotton leaf roll dwarf virus. So when does it come in? How severe is it? And how much of a concern it should be to growers in this area. So for the first time, we've used the Midville station to take part in a regional study where we're looking at the impact of cotton leaf roll dwarf virus as a part of this regional study based upon planting date and varieties. And that information will be available not only regionally, but at our grower meetings as well. We can only do that work here. I'd like to talk about corn and soybeans here. And corn and soybean work at Midville is important for a couple reasons. The first off is in the Midville region, in this East Georgia region, there's a lot of soybean production and there's a lot of corn production centered around this area. So getting good information is important. The second thing is the two most important diseases that affect the soybeans and corn are both rust diseases. There's soybean rust and there's corn rust, southern corn rust. Now they're sporadic in nature. They don't overwinter here unless kudzu survives the soybean rust. They have to come back in. And when they do come back in, we want to let the growers know. If they're not here, we want to let the growers know that too, because they can save on fungicide application. And we have a team here. It's built around the staff here at Midville, which is led by Anthony Black. We have our county agents who are our delivery system. We get them the information. We have both the Corn Commission and the Georgia Soybean Commission who fund these projects, and then we work with the growers. And then on an every week basis, we come up and sample the corn that we have planted early, the soybeans that we have planted early, and we scout for the first indication that there's Asian soybean rust, the first indication that there is southern corn rust. Now, I can tell you that we have southern corn rust in southwest Georgia. We have Asian soybean rust in southwest Georgia, but we have not found it here in East Georgia, especially in Midville. And what's that mean? That means the growers further south and west of you need to be prepared, need to be spraying. But because we have these sentinel plots, we're able to look and see when is the disease coming close to you, when do you need to invest your fungicide applications and your money to protect them. Again, this is the canary in the mine shaft for you. We're watching here in Midville, trying to determine when the growers in this area need to be prepared. We're watching not only for soybean rust and for southern corn rust, we have other diseases. I picked some corn here today. We have corn smut. We're watching for corn smut, northern corn leaf blight, southern corn leaf blight, gray leaf spot, frog eye leaf spot, any number of different things on the soybean and corn crops to be able to let you know. And again, it's the cooperation between our county agents, the staff here, our commissions, our growers, and the University of Georgia and the Plant Pathology Department to make this possible. Okay, in conclusion on my part, I'd like to take this opportunity once again to thank you for taking your time. Even though you can't be here in person with us, take your time to learn more about what it is we do and why it's important. If this information wasn't important to you, without the cooperation from our industry cooperators who do a lot to fund and to help us in deciding what needs to be looked at, if you as growers, you as industry weren't interested, we would not be here. My job as an extension specialist at the University of Georgia would be less important. So I want to thank you. And just to cap, what do I do here? We have the opportunity to look at peanut diseases and fungicides that we can't look at anywhere else. This year we're looking at cotton, leaf roll dwarf virus, a new disease. Does it matter here? And if it does, when does it? We're doing that here this year. And then we've got sentinel plots looking for corn rust, soybean rust, and other diseases to give the growers in this area the heads up and give them the opportunity through our county delivery system and our county agents to take the best management decisions and best decisions to make profit for their crops. With that, I thank you for being here, and I look forward to seeing you in person next year at the 2021 Midville Field Day. Thank you.
Greetings. This is a presentation being recorded for the Southeast Research and Education Center Field Day in Midville, Georgia. This is research being conducted by Brad Davis for his master's thesis project under the direction of Dr. Scott Tubbs in the Crop and Soil Sciences Department at UGA. The title of the project is Replant Decisions in Dryland Cotton. There are many causes for poor seedling emergence early in the growing season, and this can result in reduced plant populations compared to the original seeding rate. Some causes may include cool soil temperature, seedling death due to bacterial infections prevalent during the early season, soil crusting that impedes the seedling from emerging, water buildup in low-lying areas that can waterlog the seed and ultimately end in plant death, and differing soil textures that can give rise to a combination of some of the previous mentioned problems. Pictured here are several fields with low-lying areas. These can be common in parts of Georgia. And this can illustrate what can occur after a heavy rainfall can do and lead to drowning of the plants and seedling death. This is a field that's been affected by Pythium and has caused some non-uniformity or skippiness throughout the field. There are other troublesome bacteria that can cause cotton farmers problems with seedling emergence and plant stands, such as Rhizoctonia and black root rot, which cause similar problems in plant stands. The objective of the present study at the Southeast Research and Education Center is to identify the rate of loss for cotton yields as the percentage of missing row increases. Also, we wanted to identify the trigger point for farmers to replant in order to maintain their yields. Pictured here are several plots that show the treatment effects. Uniform plots are in the foreground, and several skippy or non-uniform plots with random gaps are observed in the background. The data being presented here are from two locations of the trial in 2019, Midville and also in Tipton, and it's being replicated in Midville in 2020. We used 3 glyphosate-resistant cultivars, Delta Pine 1612, 1614, and 1646. We also used a glyphosate-susceptible cultivar, DP399. 3 seeding rates were used. These included 3.8 as a high heavy population, 2.5 as kind of a medium population, and a sparse population of 1 seed per foot. In order to establish different levels of non-uniformity and gap lengths, 3 different seed ratios of glyphosate-resistant cultivars and glyphosate-susceptible cultivars were used. This included 100% resistant cultivar with 0% susceptible cultivar, illustrated in this picture A, outlined in white. We also used a 75% resistant to 25% susceptible ratio in picture B, outlined in yellow. And then a 50% resistant cultivar to 50% susceptible cultivar, illustrated in picture C in blue. The traditional cultivar was terminated in order to create uniformity or non-uniformity in the field and random gaps with random gap lengths. Glyphosate was applied 10 to 14 days after emergence, and the susceptible cultivar is outlined in white boxes in the picture on the far right. And then the senescing plants or susceptible plants, glyphosate susceptible plants, are outlined in blue, and those ended up dying off and creating gaps in the field. In these pictures we see the 1 seed per foot seed rate with 50% population, which was the worst case scenario, at 37 days after planting on the left and 63 days after planting on the right. We see that the plants were unable to completely fill in the gaps within the rows, which is more evident in the left row where the consecutive gaps were larger. However, in the right row, there was a greater tendency to compensate and fill in the gaps, although the question is, was this compensation enough? So this really leads us to some of our results slides. You see an aerial photo of one of the fields on the left here. And the question we're asking here is, what effect did percent missing row have on lint yield? So we can see a lot of variability in the gaps throughout the block in the picture on the left. Extremely poor stands have much fewer plants in them, and then there's other plant stands that are much more uniform with higher seeding rates, even at middle seeding rates, that had more uniform gaps, or more uniform plant stands and fewer gaps. The graph on the right shows the percentage of missing row on the horizontal axis and the cotton lint yield on the vertical axis. So as larger proportions of the field had larger sections of row missing, yield was significantly affected in a negative way. On average, this trend line demonstrates a 52 pound per acre decrease in lint yield for every 10% of missing row. This graph illustrates the relationship between plant population and lint yield. Plant population is on the horizontal axis, lint yield again on the vertical axis. And if we look at the area on the red line past the 2.5 plant per foot mark within the blue box, we see that there is very little difference in yield. The line is plateaued and very close to flat. This flat line indicates little to no change. There's an indication it would not be beneficial for us to have plant populations this dense. So we look to identify the optimum point to where we can maintain yields. And this was noticed at the 1.77 plant per foot mark as being the optimum. This means a population above this point would be comparable to one another in relation to yield, and anything below this point could be the potential loss of yield. We saw that the missing row percentage did have a negative effect on yield, and we also saw that yield began to plateau at 2.5 plants per foot, and likewise a plant population of 1.77 plants per foot would result in loss in yield with diminishing returns. We would like to acknowledge the staff of the Southeast Research and Education Center in Midville, especially Mr. Anthony Black, and also Travis Woodard for his help in maintaining the field. This project also is not possible without the assistance of technical research support in Dr. Tubbs' program, including Mr. Zach Cromer and the fellow graduate students on this project. It's also a special recognition to Cotton Incorporated and the Georgia Cotton Commission for providing funding and support for this project. If you have any questions or comments related to this project, we welcome them. You can see the email for Dr. Tubbs and for Mr. Davis in the bottom right corner of the screen, and we certainly thank you for your attention today.